Welcome to another episode of Agentic AI, the future of intelligent systems. In our last episode, we explored the rise of the agent economy, a world where intelligent systems transact, negotiate, and collaborate across digital ecosystems. But here is the truth behind that future: none of it works without engineering. That is why I believe it is time to invest not in more AI tools, but in AI engineering. Tools come and go: new APIs, new copilots, new integrations. They promise productivity shortcuts, but tools alone rarely scale. Engineering, on the other hand, is what turns potential into performance. It is the difference between an impressive demo and a resilient system. Agentic AI, like any real technological revolution, is 90% engineering and 10% imagination. It requires a foundation: architecture, data flows, observability, optimization, ethics, and sustainability to make those agents reliable, safe, and efficient. Yet today, many organizations are chasing tools instead of building discipline. They experiment endlessly, but they do not standardize workflows. They buy models, but they do not measure cost or carbon. They connect APIs, but they do not secure or govern them. They deploy agents, but they do not ensure responsible behavior. Without engineering maturity, even the best AI ideas collapse under their own complexity. Engineering is what bridges the gap between vision and reality. It turns experimentation into execution. AI engineering starts with architecture, designing systems that are modular, observable, and scalable. It requires defining workflows, data boundaries, caching strategies, and fallback paths that prevent runaway loops or redundant compute. Then comes measurement. You cannot optimize what you do not measure. Energy use, latency, cost per query, and carbon emissions are not abstract concerns. They are engineering inputs. In a future where efficiency defines success, visibility becomes your advantage. Next is resilience. Agents will fail, APIs will time out, prompts will misfire. Engineering means designing for failure, graceful degradation, retries, and safety nets that keep experiences smooth and trustworthy. And finally, responsibility and sustainability. As AI workloads scale, so do the ethical and environmental footprints. Responsible AI engineering ensures fairness, transparency, and human oversight. Sustainability ensures that compute resources are used wisely, that cost, carbon, and water are treated as first class metrics, not afterthoughts. The point is simple: tools make experimentation easy, but engineering makes innovation last. Look at any major technological transition: the cloud, mobile, DevOps. In each case, the breakthrough was not just the tool set, but the engineering mindset that matured around it. The same shift is coming to AI. Those who invest in building engineering culture, reusable frameworks, and shared infrastructure will lead the next decade. And this is not just a technical shift, it is ethical, it is human. As organizations evolve, they do not need to replace people, they need to augment engineering talent, upskilling teams, integrating new capabilities, and embedding ethical and responsible design principles into everyday workflows. This transformation is not about reducing jobs, it is about expanding capacity. It is about creating engineers who can think systemically, balancing performance, safety, and sustainability in every build. The winners of the next era will not be the ones who collected the most AI tools. They will be the ones who built the strongest, most ethical, and most sustainable engineering foundations beneath them. That is why organizations must focus on building and augmenting engineering skills, not eliminating them. Invest in AI engineering because that is where reliability, responsibility, and trust begin. Thank you for listening. Until next time, remember the next AI revolution will not be built on tools, it will be engineered.